All right. Thank you guys for coming here like very early in the morning, 9:30. I'm a developer, so I usually don't get up this early for getting started with WebGL and Three.js. And I apologize for being slightly impolite by having a lozenge in my throat, but yeah, I came from Rome to here, and it was a total shock to my body, so I apologize for that in advance. My name is James Williams, and let's get started. A little bit about me. I wrote a book called Learning HTML5 Game Programming. It came out back in October of 2001. It's still good, so you should go out and buy it. I'm writing a new book on Three.js, kind of a self-published thing, just because traditional publishing is a little bit slow and it's kind of an experiment. So yeah, so there's Learning HTML5. Definitely buy it. And the new one, Three.js by example, is a lot of the content from this presentation, and it's a LanePub book. So it's, I think the price is at like $3.99, but you can always pay more than that. And you get updates as soon as I push them. And there's about like 42 or 50 pages so far. So as far as the agenda for today, what we're going to be talking about, we're going to start with WebGL and Three.js and go into specifics of how to create meshes, how to lay out scenes, work with shading and lighting, and a little bit about physics and a bunch of demos trickled throughout. So WebGL is a low-level graphics API for JavaScript. It's based off of OpenGL ES 2.0. So that's the OpenGL that you would have on, say, your Nintendo Wii, your PlayStation, your any of your consoles, Android, iOS. They all use OpenGL ES2. So just for a quick poll, who in here is familiar with OpenGL? Okay, cool. All right. So yeah, so OpenGL ES2 is basically a subset of the full OpenGL that you would have on a regular computer. And WebGL is a JavaScript version of some of that. It uses the canvas tag, and on most browsers, most modern browsers, meaning not IE, it's hardware accelerated. Just a quick note, WebGL is not supported by Microsoft because they're Microsoft. So there's a good reason why this talk is about Three.js and not raw WebGL. It's just that, okay, so I'm going to switch to just my one of my demos real quick. And that one, you didn't see any of this yet. Okay, UI. Oh, my UI is on. And then let's capture just a single frame. So from that single frame, with pretty much nothing on the screen, this is everything that you would have had to contend with in WebGL, which is kind of insane. All right, go back to slides. Here. So, move that away. Okay, so yeah, so as we could see from that slide, there's lots of code that you have to contend with. It's not very fun. You have to think about management of like vertices and all that type of stuff, and it's not very welcoming to beginners. Excuse me for a second. I was running in the metro earlier today. So Three.js is a scene graph library over top of the WebGL nastiness that makes it very easy to target either Canvas 2D, WebGL, and then there are other renderers like for SVG, and you can do a lot of stuff with CSS3 with like moving around divs and things like that. You can import models from Blender or Maya or 3D Studio Max, pretty much any of your major 3D modeling applications. You can export stuff. Excuse me. So let's get started with creating a basic app. So a basic app is going to comprise of a scene, which is kind of the world that we're drawing everything in, a camera, which is how we see the world, a renderer, which actually draws the world, and then we can have lighting and materials to color the world and make the world more interesting. So that last line down there is for our camera, just a perspective camera that we set up with our field division. That's the angle either side of the center point of the camera to control how much we're seeing in the world. The near and far viewing planes kind of shrink down the world so that we don't render stuff that's behind the camera. The target is what we're looking at, and the up vector is how the camera is oriented in the world. So in this next slide, we have a basic scene, and I apologize if any of you guys are averse to CoffeeScript, but I think it's awesome, so that's why I used it. We start out here with a WebGL renderer. We set the background color of our world is going to be black, and then we set a size to the world. Next, we set up our camera with our field division and all that stuff. We situate the camera back 100 units on the z-axis, and we create our scene. Excuse me. This next two lines of code here is where we're actually taking the renderer, which the renderer creates a canvas tag and inserts it into the page. So so that's what we're putting into our container. And then lastly, we close with adding the camera to the scene and rendering the scene for a specific camera. So there are a bunch of meshes that predefined meshes that you can use in Threejs for spheres, planes, cylinders, cubes, all that types of stuff. And the top line there is how you would create a mesh. You would instantiate a specific geometry, either one of the preset geometries or something that you imported from another file, and then add a material to it. There are a couple different materials. This one is showing a basic material, so it's just a matte color, but you have materials for Phong shading, for Lambert shading, any types of interesting sort of effect that you want to do with material. There's either a base way to do it, or you can do it yourself with shaders, which I'll talk about in a little bit later. So here's another example of how you can do vertex shading for an object. Now, if any of you guys are familiar with like the game dev OpenGL tutorials, this is kind of a version of that where you have a triangle that has each vertex shaded in a different way. So if we go over to our code, okay. Okay, our server is going. And move this down. Okay. All right, I think that was okay. So here is a basic triangle and square, and let me go over to this one so you can see the code a bit better. And CD and demos. Okay. And styles and oh no, that's demos. 3, 2. Sorry about that. All right, my code's weird right now. But let's go to the next one, and we can see this is how we used that one before with the vertex colors. How we have a red, a green, and a blue, and they all kind of meld into one. All right, and going back. All right, as I was saying before, you can load models from a bunch of different applications like Blender. You can use Collada models, Object Wavefront, a bunch of different everything. So this next slide shows how we can load a model. Now you start with a JSON model and you call the load function there with the URL of where the model is located and the callback for what you're going to do with the model after you finish. And the callback, in this case our hero callback, returns a geometry with the list of vertices and faces and all that type of stuff, and also the materials that are referenced in the model. So just like before with a regular mesh, we create a mesh with the geometry and the material, and then we can add it to our scene. Excuse me. So loading a scene is very much the same thing. Instead of a JSON loader, we do a scene loader, and that scene loader also has a load function on it. One of the key differences is that for a scene, especially if you have a large scene, you can set a progress function, and the progress function basically just returns what has loaded at that time. So you can have a scene that's gradually loading instead of it being all blank and then poof, everything is there. There's also an editor for Threejs. It's not very advanced, but it's very nice in giving you something that you can get models on the screen real quickly and mess around with how things work. And just to show you that real quickly, hopefully internet works. Okay. So here's the Threejs editor. One of the cool things about this is you can set the renderer for the scene, so you can run this in IE if you had to. Excuse me. And you can, ooh, it goes weird when you move it back from canvas. Okay, so you can add objects like cubes and stuff like that, and you can move it around. You can also set the materials on it here. You can even texture it if you want. And then another cool thing is that you can export either a individual file or you can export the whole scene. All right. All right. Oh, and I did that demo already. Okay. So so what if you have a scene or effect that you want to do that's too advanced for a built-in material type? Well, what you would use is a shader, and shaders are using the GLSL language, which is a very C++y type syntax to target the GPU and the graphics pipeline. And you can edit stuff on both a vertex level and on a pixel level. Vertex shaders, as I was saying before, they run once per vertex in a mesh, and they can alter the color, position, or texture coordinates for that specific vertex. Here is an example of it, and as I was saying before, it's very nasty C-ness. This one doesn't do anything except for determine what the world space is from the how a vertex is going to be oriented in the world based off of on the mesh, actually on the canvas, based off of how it's oriented in the world. Sorry. And pixel shaders run once per pixel in a mesh. They can do things like bump mapping, shadows, that sort of thing. It only knows about the pixel that it's working on. So if you need to sort of pass messages between the fragment shader and the vertex shader, you would use a thing called a uniform, which is just kind of a variable where you can pass things back and forth. And here is an example of a fragment shader. And this for the class participation part of the talk. Can anybody tell me what this is doing? Anyone? Come on, yell it out. I can't hear you. Yes. If I had a cookie, I'd give you a cookie or something. Well, actually, no, because I'm kind of phlegmy and I don't want you to get sick. So yeah. So that does a green color for every single pixel in a mesh. So just imagine the code before that we did where we just did 3-mesh basic material and set a color. This is what's being generated behind the scenes for that. And as I was saying, we can do very advanced stuff like this is for tune shading. So it's basically a way to shade things where it kind of makes it look more cartoony and over the top. It kind of simplifies it a bit. So let's go and I can show you better than I can tell you what tune shading is. We can do this one. Scroll down. So this is an example of tune shading. So this is just to show you the types of shaders that you can do. And there's also another one called ShaderToy, which allows you to go and play with different types of shaders. I'm not going to do it on this computer because I'm already running a bunch of stuff, but I advise you to go here and check it out to see what you can do with different types of shaders. Did that. As far as collision detection, coming back to gaming a bit, every mesh in Threejs has the components inside of it to compute a bounding box and a bounding sphere. You can also facilitate collision detection using rays and planes as well. If you're using a library that doesn't do it as well, like if you're using a physics library that doesn't do good collision detection, you can do it yourself. Excuse me. And with physics, there is a library called Fizzy GS. It integrates very deeply with Three.js in that you can change just a couple lines of code and make a scene physics enabled. For the people that are coming from maybe C++ or whatever, it's built upon Ammo.js, which is a port of Bullet from C++ and C-land. And as we can see from this, the things that have changed are the top two lines of the code snippet, where we're setting a couple of Fizzy JS things. We have, instead of a 3-dot scene, we have a Fizzy JS scene. We're setting gravity, and instead of a 3-dot mesh, we're having a Fizzy mesh. And one more addition is that instead of just a renderer, we have scene.simulate. And I'm going to show you a very slow running physics scene, mainly because I'm working on a Chromebook from like 2 years ago. So the first thing it does is it loads a scene, because this is a scene that's loads. And then we have a very hesitating physics engine going in the background. But this is more because my hardware is kind of slow. It will run faster on your computers. All right. that. Okay, what I wanted to do for this talk is create a simple game, and I'm just gonna tell you a little story, which kind of unfortunately dates myself a little bit. This is my very first computer. It's a ColecoVision Atom 2. It came out in 1982, back when I was one, and it stopped. They stopped selling it like in 1983 or something like that because they just created way too many of them, and that was around the same time that Atari like crashed, and because they created like a bunch of ET games that are in landfill somewhere in Arizona, I believe. So one of the key features of the ColecoVision Atom is that it had a tape drive, which you can see on the front there. It had a 525 floppy drive and a 2-deck tape drive. And a lot of the software was loaded on the tape drive. And it would take something like 5 minutes to load a game. And it would spin very high, fast, screechy in one direction, stop, spin to another position, stop, spin back, stop, and then it would start up a game. And there's no monitor there because you would hook it up to a TV. So the very first computer game that I've ever played was Buck Rogers in the 25th Century, which apparently was like a TV show in the 70s or something, I don't know. I couldn't find any versions of it from the ColecoVision Atom age, so this is a slightly newer, upscale one from Sega. So if we go over to our demos, and it's not that server. And run it. Okay. And this is the same thing that we saw before, where we have, and the lights are like so bright here, you can't really see it. Sheesh, it's like so dark. Okay, give me 1 second. I'll fix that real quick. And go up, game, coffee, and where's our ship? Okay. Okay, here's our hero. Yikes, sorry. And we're just going to change that color to that, and then while we are up here, yeah, that should be fine. And let's restart again. And still can't see it because I have like, good, okay. Well, the awesome thing that this is demonstrating for you is that you can, one of the cooler things about creating a game with JavaScript is that you can edit a lot of the stuff on the fly, even with the server running. And there we go. Okay, so we can move our ship back and forth and up and down. And I don't have any collision detection in this yet, but we can move around gates, and we have flying saucers that are randomly sort of instantiated here. And the amount of code that I had for that is less than 168 lines of code in this one, and then there's another smaller file with like 50 or 75. So that, oh, that's right, okay. WebGL Inspector. Now I showed you this a little bit before with, I have the extension installed right now, but it gives you a little UI that says capture and UI to capture frame or show UI. So let's capture frame and then pull up the UI. One of the other things that I didn't tell you when I was kind of horrifying you with this code before is that if you click a line, it shows you in this little box what all the instructions up to that line executed. So if we keep on clicking, we can see we're just getting to something that's drawn at line 29. We can also, you can also see a state, a sort of snapshot of what's going on in your system. You can see whatever textures you're loaded. For this one, it's just going to be a matte black because I haven't loaded any textures here. And you can see the buffers for the vertices that you have. And you can also see your shader programs. And for Three.js, a lot of this is generated for you, so you have a bunch of stuff that you're not even using. And I just realized that I did not show you guys textures, so I'm going to go and show you that real quick. CD demos. And all right. Okay, now let's reload that. And I think my, ooh, is that the right one? Oh, my bad. Demos. Okay, there we go. That's the one. Okay. And I think my textures, okay, so this one we just have a rotating triangle, and a way that you can do that is for each object you have a position and a rotation object, and the position and rotations have X, Y, and Z, so you can do rotation .x and add to it and make stuff rotate or move. And then we have a texture here, and I don't know if you can see it there, but it's pretty much just one line of code where you're calling image utils load texture, and instead of adding a color for your mesh basic material, you just add a map and then that texture. All of this code is online at github.com/jwill, JWILL, under Three.js by example. So if you're interested, go check that out there. And that is pretty much all I have, so I wanted to leave some time for questions. Anyone? Oh, there you go. I couldn't see you in the back. Sorry. Yes. Okay. Well, it pretty much just tracks to what is supported by WebGL. Android does have WebGL support in the Chrome beta, like I think it's version 25 or 26. So that probably will trickle back to the baseline Chrome. Whether that materializes in all of the kind of versions of Android that you have, like with, you know, TouchWiz and Blur and all that crap, that's neither here nor there, but you probably will have it in mainline Chrome very, very soon. As far as iOS, I haven't really researched that as much. Cool. Anyone else? Yep. Oh, I'm just using Vim with, there's this application on Linux called TeamOx. So that's what I'm using to have the multiple views. And mainly this is because I'm using what is supposed to be just a consumption computer, a Chromebook, and I'm using it to do development just because, I don't know, I'm a masochist or something like that. So yeah, so the main part of this is just Vim, and I just do TeamOx because I don't want to have to pull up multiple consoles. It's on the client side in the browser. You can precompile your stuff to JavaScript. Like if I were shipping this game or something, I probably would precompile it because you do take a performance hit by writing it in CoffeeScript and then having to translate it to JavaScript and then run the JavaScript. But I like it because it's a lot less code. So it's kind of very much the type of thing that you experience if you use like JRuby or Groovy versus hardcore Java. It's doing the same job, but it's getting it done a lot faster. Anyone else? Yep. Okay. So the question was about the quality of the JavaScript code that's generated from CoffeeScript. What's that? Oh, resource intensive? Okay. I mean, well, the goal of Three.js is so that you don't have to dip into the WebGL layer. I mean, that's the main point of it, is like, if you're doing things right, you shouldn't have to go and manipulate stuff in WebGL land because that's where you're more prone to make errors. Dang, my nose is running. This is gonna look crappy on tape. I'm gonna look like a refugee or something. Sorry. Just sickly person, not refugee, sickly person. But yeah, if you're doing it right, you don't have to worry about manipulating stuff on a pixel level or worrying about making arrays for vertices and aligning them and all that type of stuff. I mean, you can do that, but if you're going to be preoccupied with that, you probably would start in WebGL land and stay there versus saying, okay, I'm going to use Three.js and then I'm going to sort of try and funge with the lower level stuff. It's kind of trying to attack it at both ends instead of sticking to one task. Anyone else? Okay. Oh, there you go. Okay, the question was about getting free and open source models. I do not have any resources like right on the slide deck, but I think the name of the thing is like open source. It's like open game models or basically there are lots of places. Just searching for, I just typed in like Blender models open source and I found like 5 different websites. One of them is Blender Swap, I believe. I can't think of any names, but there is definitely a lot of stuff out there for finding open source models that you can use in games and stuff. And I think there was one over here. Yeah. Well, there's a reason why WebGL is only in Chrome beta. Like, if you're pushing a production app, I don't think you should be at this point trying to do it for targeting a mobile browser. I think probably the best thing for you to do if you have a game or something like that is to stick to an Android or iOS sort of development cycle for that part, and maybe do WebGL for the desktop version and hope that they'll eventually converge, as opposed to trying to shoehorn WebGL into a mobile space. Yep. Anyone else? Okay. Thank you guys for coming. I apologize for being coffee and phlegmy, but that's how London happens. If you had this in a warmer climate, I'd be awesome. So thanks for coming.